MCE5 is nonetheless a major evolution. It completes the technological content of internal combustion engines with an essential functionality, the variable compression ratio. From the outside, it's difficult to see what differentiates an MCE5 engine from an ordinary one. One would think it is a conventional gasoline engine. Its architecture and dimensions are very similar, as are its noise and vibration behavior. The difference is inside. MCE5 is the combination of a conventional rod crank system with gears like those found in gearboxes. This arrangement, exclusively based on mechanics, radically improves the engine's capabilities in terms of performance, fuel efficiency, and pollutant emissions management. The figures speak for themselves. Coupled to a two-stage turbocharger, the MCE5 engine can multiply torque by 3 and power by 2, with significant safety margins. This means that it's possible to produce a 1.5-litre cubic capacity MCE5 engine with the power of a 3-litre V6 and the torque of a large diesel. MCE5 applies downsizing and downspeeding strategies with unparalleled efficiency, which leads to an initial fuel consumption reduction of roughly 25%. Moreover, the MCE5 engine can, at any moment, adapt its compression ratio to each driving situation. This function increases the engine's energy efficiency by an additional 8 to 12%, thereby allowing fuel consumption to be reduced by up to 35% with respect to the reference European driving cycle. But that's not all, since the compression ratio is a fundamental characteristic strongly affecting physical and chemical combustion phenomena. For this reason, compression ratio control opens up prospects that are unconceivable for conventional engines. In the short term, MCE5 will, for instance, permit the implementation of the high-efficiency Atkinson cycle. It will ensure optimum combustion quality even under high EGR ratios. It will also permit the ignition of the charge by compression over an extended range of engine loads and speeds. The MCE5 engine will also bring back to the foreground lean burn strategies by providing them with the efficiency they currently lack. MCE5 also opens up the possibility of consuming different types of fuel, including natural gas and biofuels, with the highest possible efficiency. MCE5 pushes back the limits of all automobile engine strategies without any risk of reducing their efficiency. MCE5 technology is a critical key that opens up a new era, that of variable compression ratio engines. These engines, also called VCR engines, will transform cars to make them more attractive, cleaner, and more fuel efficient. VCR strategy has been around for quite some time. So why MCE5 rather than another technology? The answer is simple. It's because MCE5 is by far the most efficient and highest performing of all the VCR technologies designed to date. This guarantees the effectiveness of the VCR strategy. Let's have a closer look. MCE5 offers the widest control range that exists, with a compression ratio that varies continuously from 7:1 to 18:1. MCE5 also offers excellent precision of plus or minus 0.05 of a millimeter, with a compression ratio actuation speed of a few dozen milliseconds. MCE5 is also the most flexible VCR technology, allowing individual compression ratio control for each of the engine cylinders. Due to this, MCE5 is the first and only intelligent VCR engine to propose a floating compression ratio, meaning that it constantly adapts to the physical characteristics of each cylinder. MCE5 also offers excellent mechanical efficiency with friction losses that are lower than those of a conventional engine with a comparable performance level. Hence, it safeguards the know-how of engine designers by using a conventional combustion chamber as well as standard and invariable piston kinematics. MCE5 can be integrated into any type of vehicle. It is robust, reliable, and durable. MCE5 is a technology based on general mechanics with low noise and vibration emissions. The functionalities and characteristics of MCE5 technology remain unequaled and open the road up to important reductions in greenhouse gas and pollutant emissions without reducing vehicle performances. Initially designed in 1997, MCE5 technology has been through different programs focusing on the validation and then the step-by-step improvement of its components. These programs, co-financed by the French government, cost nearly 20 million euros and involved over 45 European companies. In parallel, scientific studies were carried out to determine and test manufacturing processes adapted to each MCE5 part and intended for a production level of several thousand engines per day. For example, Ascoforge and the Ceram developed the high-precision forging of the gear wheels and racks. At Danielson Engineering, the cylinder head and engine block were designed to meet the requirements of mass production casting and machining. The MCE5 connecting rod and crankshaft were designed in collaboration with companies that produce several millions of them per year. The forging processes selected for these parts are those already used in the automotive industry. The cost price of each basic part, which do not require specific manufacturing processes, were identified. All of this work has demonstrated that it will be possible to mass-produce the MCE5 engine in the near future. It also showed that in the worst-case scenario, the additional cost to produce an MCE5 engine and its turbocharger is in the order of 500 euros, roughly the cost price of a diesel particulate filter. Used to replace a large V6 gasoline engine, the MCE5 generates savings of approximately 800 euros per vehicle while offering the same performance level. At equivalent or even lower energy consumption levels, a vehicle equipped with an MCE5 engine is less expensive than a diesel vehicle and much less expensive than any hybrid vehicle. At this type of energy efficiency level, the cost price per kilowatt of power or per newton meter of torque offered by the MCE5 engine is below current standards. In 2008, after 11 years of research and development, MCE5 technology has reached a first maturity phase, making its mass production possible. With over 1,500 hours of testing, MCE5 delivered on the test bench its specific fuel consumption, friction losses, torque and power performance levels. Despite the fact that it is new, the MCE5 engine already proposes a performance fuel consumption ratio that no conventional engine, as modern as it may be, can aspire to. Thanks to its effectiveness, MCE5 is also bringing up to date the exceptional prospects opened up by the variable compression ratio when served by high-performance technology. Thanks to MCE5, the variable compression ratio will become standard equipment of automobile engines, alongside variable valve timing, supercharging, and direct fuel injection. The intelligent cooperation between these technologies will sustainably preserve the competitiveness and appeal of cars. This cooperation is a tangible and rapid solution for the automotive industry to meet today's environmental and energy challenges.